Good evening, everyone. I would prefer to speak with you on an on-site meetup in the Nordic, but today I'm going to meet you with from my living room. And since my computer was almost burning down in my first attempt, both by recording to screen and the myself at the same computer, I'm using my own computer to record myself, and I'm using my work computer to record the screen, and that's why I will be looking at my work computer. And please don't mind if I'm checking, like looking at this way. Okay, let's start with talking about. Today I'm going to talk about observability and debugging for serverless applications. And before jumping to presentation, let me introduce myself. I'm Emrah Samdan. I'm the product manager, VP of product for Thundra, and you can find me on Twitter with my name. And I'm working as a product manager for almost 3 years now. I was a product manager I was a developer for more than 6 years before I transitioned to a product manager job. I'm highly engaged with the serverless community. I'm the co-organizer for Serverless Days Istanbul and Serverless Turkey meetup, and I'm the organizer. I'm the co-organizer again with the Serverless Days Virtual, which will be next week, and I'm co-organizing with my dear friend Gunnar Grosch and Stanley and Farah Campbell. And let's talk about today's agenda. Today we are going to talk to you about Thundra's story, which is kind of interesting, and then I will just mention that why would you need a solution like Thundra, and then after that, like I will be mentioning like how Thundra is actually working under the hood, and I will present our approach to serverless observability by walking into a demo. Let's begin with the Thundra story. Thundra was born in Epsagon back in 2017 because Epsagon wanted to build something with serverless technologies, and as an incident management company which is actually monitoring everything very closely, they need the same level of monitoring with Lambda. But they look at the market, but they couldn't see a solution which will be in the same quality that they used to be. And our CTO Serkan built a instrumentation library for Java Lambda applications just to check what's happening in the Lambda functions. And like since that day, Opsgenie is using Thundra, and we are accustomed to the process like millions of events, and sometimes it goes into even like billion per day. And in 2018, we had to say bye to our mother company Opsgenie because it got acquired by Atlassian. And before it's getting acquired by Atlassian, they actually decided to build Thunder as a standalone product, and they hired me as a product manager for that. Before the acquisition, we brought support for Node.js and Python, and we started to be just building a nice UI for that. And after the acquisition is finished, we spun out of a new company. And last year, 2019, was kind of the year of growth for us. We speak like hundreds of customers and serverless users. You might be one of them because I spoke like really many people. We added like tons of features, I will talk about in a minute, and we achieved the DevOps competency with AWS. And this year we extended our offering to not only for observability but also for debugging and also security, and we also extended our offering to non-serverless components like containerized applications. But like I will keep the focus on serverless and observability, and I will just mention debugging a bit in this presentation. So let's talk about like why actually would you need a solution while there is CloudWatch and X-Ray. Why would you need a third-party tool like us and our competitors? And it all just starts with this funny story that like when you start with serverless first, you start with as a Charmander, and you start with like you just put a function behind the API gateway, and this function gets triggered by API gateway and writes the results to a data store, which can be NoSQL or SQL. And after a while, you turn out to be a Charmeleon, which is like a event-driven architecture in which the several Lambda functions are working together. And after a while, you have several event-driven architectures which are actually communicating between each other, and you have a very complicated event-driven asynchronous architecture composed of Lambda functions, managed service, unmanaged services, and so on. And like understanding such an architecture using CloudWatch and X-Ray might be problematic. Since you don't have the access, the underlying infrastructure, all you have is the logs and the metrics provided by CloudWatch and the traces provided by X-Ray, but they have all limitations. And just checking up the one function is not enough. Remember the Charizard thing. And in this view, there are like many other third parties that can't be actually traced by X-Ray. And also like you should ask yourself that how would I understand when I have like a complicated architecture? If you want to build your own, it's like you can group the logs according to functions and invocations. This will be considerably easier. But when you want to implement your own way of tracing, you need to just add the correlation IDs to the traces and just aggregate them at the background. And this will actually take a lot of time. And if you want to build something like local tracing, as Thundra do, just to see what happened in the application line by line, post-production debugging, it's also another problem. And just think about like building it and maintaining it. And for this reason, we say that like use it as a service solution like ours, which works automatically, which doesn't require you to instrument every single thing, which works automatically, but gives you a room to let you embed your own instrumentation and your own tagging mechanism. So we are approaching the serverless problem as an application health problem. It's not about just observability. We are looking at from a more holistic way of like we believe that like there is this application health should be sustained in the serverless applications, and the pillars of it is observability, debugging, and security and compliance. And observability, as you know, like has already its own pillars. And as I said, like we are providing observability solution, which is kind of a like very complete. And I can accept that our security solution is still under construction. And debugging, we also solve this problem with like our debugging and chaos engineering solutions. These are kind of some basic feature functionalities that we are providing. For example, you can do anomaly detection and automated actions. You can look at the dashboards and reporting, which can also be customized, and you can use the tagging mechanism and debugging, and using that, you will have like a nice view of understanding of your architecture. So I think it's time to actually try to understand how does Thundra work at the background. So Thundra has two ways of integrating itself to your application stack. Let's think about this is your application stack. We are providing a CloudFormation template which automatically connects to your log groups of your functions and also other services and gets metrics and logs from these. And if you don't want to just use this CloudFormation template, if you don't want to give access to all the logs of your functions, you may skip this step and use the automated instrumentation. Automated instrumentation mainly aims to gather the tracing, but if it's not used, if the CloudWatch integration is not used, it also gathers the metrics and logs. And automated instrumentation works in a way that you add our Lambda layer to your serverless functions, and you are just adding our the API key to your functions, and you will be actually instrumenting your applications automatically. You don't need to change any code. You don't need to add anything to your application. You are not polluting your code, but at the same time, you are gaining a very good visibility. And adding this Lambda layer, as you may guess, is possible by CloudFormation. It's possible by AWS SIM, serverless, and Terraform, and other solutions. And after that, when you receive all this data when you forward all this data to Thundra, we are just like putting it at our ground, and we are providing real-time analytics that can be used to have anomaly detection. We are providing real-time debugging facilities, and we are providing AI-driven recommendations, and you can set up alerts on top of this visibility, and you can forward the alerts with the popular incident management platforms like PagerDuty, Ops Genie, or VictorOps, or to Slack, and to email and Amazon EventBridge, which is kind of my favorite one in the recent days. And we are also providing a application level firewall which controls your outbound traffic. But like, let's skip this for the sake of observability for this meeting. So this is how we see the observability problem in serverless. So we, as like since we are also using serverless in our application, we see that like there are some data models or just like the measurements of code in a serverless architecture. So from bottom to top, you have code blocks in your functions, and these functions are being part of transactions, which event-driven transactions, and these transactions is actually is used to achieve some business flows, and these business flows at the end of the day is a part of your whole service system. And for each way, we are providing several different lenses to understand how these the models are working, and I will go over them one by one. Just for that purpose, I will use a demo application, our serverless block site application that we are using in our blogs and workshops. And in this blog post, you can see that you can just add a block. For example, like this, hi Gunnar, and you can add this blog post, and after a while, after you add this blog post, you can just like list the blog post, and it has some latency, and yeah, it's appeared here. So we run a fully serverless 2 transactions. We first post a blog post, then search for like list all the blog posts. Then we can just go check on Thundra console what happens, and let's say like we can check what's happening in the last 15 minutes, and we see that like 3 functions which seems like related with the posting blog posts run, and 1 functions which seems like related with the searching blog post run, and all of its code start because I just run it now. But like, let's start with the top of the pyramids. So you can see the architecture view here. As you can see, like we draw all the architecture, and you can see this is like posting a blog post flow, and this is actually searching a blog post flow. We are just aggregating these two to understand, to see your architecture at a glance. And this diagram is actually color coded, so which means that when you see an anomaly here, you will see some edges or nodes colored as red, and when you click on these, you will see what's going wrong. For example, by click on this link, you will understand what's going wrong or nice between this blog post application and the SQS. And you can see the trend line analysis of this interaction, and you can see every single interactions that's happening here. And you see the interaction took like 100 milliseconds, and the whole application took just a bit more than this. And let's turn back to the business flows. For that, Thundra provides unique traces facility, which actually shows you I don't know, the unique traces. As you can see, you can unique traces is saved as like the trigger of it and the entry point lambda, but you can always give a new name to it. For example, you can just add an alias and say that this is a post blog post, and you can see how many times it gets triggered, what is the average duration. And since this process is kind of asynchronous, you don't need to actually pay attention to duration for most of the cases, but you can see how many times it just got invoked and how many times it gets error. And this view actually has a very important side effect. So because many of our customers are saying that if your function is behaving in a way that you don't expect, you see a unique trace here, which actually shows you an unexpected trace that your function is saying that you are not aware of. And some of our customers discovered some security flaws in their applications just using this screen. They saw, hey, I was not expecting such a trace, and it turned out that like their functions are doing something that they don't expect to do, and this works in a way. So let's look at the transactions. So now we know that like this is a post a blog post unit trace. See that how many what are the like transactions in it, and you can just go to the trace list and you can see when was the transaction happened, and just click on it to see the transaction. This gives you distributed tracing view of all your architecture. In this way, you can see that API gateway triggers this Lambda function. It just writes something to SQS, and after that, SQS writes something to like triggers another function, and this function writes this blog post to Dynamo, and Dynamo triggers another function, and writes the blog post to Elasticsearch. And this shows you like how long a function took, what are the how long a SQS took to trigger this function. It took like more than 1 second, for example. Since this is asynchronous, this is not very important, but you can still see that. And you can see the payload coming or going out from non-serverless resources. So you can see how SQS triggered the function, and you can see what was the inbound message coming to SQS. And after that, when you click on a Lambda resource here, you can see Lambda took that much of time, and you can actually instrument your methods instead of just showing CloudWatch logs. We are actually instrumenting the method itself and showing you what happened in the application. This is kind of very important and very useful. When you click on this method, actually you see the whole application code here, and you can even see the blog post object and look at like what actually happened here. And after that, you can navigate step through your application just as you could do normally. So for example, here that you can see what was the username, what was the string and the post and everything, and using that you can understand the issues. And let's say that you like to understand the invocation more closely, you can just like navigate to invocation and see the same. And here that like you can see what happened here, and you can see some other metrics. And most importantly, you can take some of the business context as an text here. And for example, like I like to search the invocations who has the same tag. Just using this navigation, you can go to the other invocations of this function, and there is no other blog post that is written by me. And you can just always write here another queries, like for example, I like to see functions whose duration is more than 100 milliseconds, which cost me something. You can see those. You can see I like to see those, and I like to see the call started true. And you can save these queries as a query and share it with your colleagues, or you can save this query as an alert policy. So you can say that I like to run this query every minute, and I like to trigger an alert when there is more than one result, let's say. And you can just like I like to assign this alert policy to all functions in my function, in my serverless stack, or to single functions. And you can add new notification preferences, as I said. Let's look at like what happens actually in the bottom of the panel. So actually, I just give a bit of hint here, but I can still show you. As I said, like you can look at the methods and what's happening here. This is what we call offline debugging. Like this is why we are calling this offline, because like we are now checking an invocation that just happened an hour ago, and this like it already finished, but you can just have a retrospect and understand what's happening there. And if you want to do online debugging, I will show you now. You need to go to switch to VS Code or VS Code application. You can start Thundra's online debugger here, and it just sets up a secure bridge between Lambda function and your VS Code. And here that it's just waiting for Lambda function to trigger. And I just made a connection with the delete blog post. And when you delete a blog post, it actually makes the process pending and starts the debug here. And we hit the debug breakpoint, and you can see the all the stuff here, and you can just like debug it line by line. You can see blog post IDs arrived here, and you can understand what happened here, and you can debug your functions as usual. I'd like to conclude the presentation for a quote from our customers. Franz Olibel from Conductor Tech says, they wouldn't be so committed to serverless if they didn't get the confidence that they got from us. Thank you everyone for joining that, and thank you that you listened to me.